Thank you for coming this morning. And let me start with a quick question. Who's a developer here? Hands up. And keep your hands up if you work with cloud already. That's nice. So, that's better than I expected. So who am I? As Petr said, I'm cloud enthusiast. I'm one of the founders of Cloud Native Czechia. We are the cloud mindset sharing group here in Czech Republic to bring the best knowledge to you, users and developers. I'm also senior engineer at Red Hat when I work at engineering department, when I work at KubeVirt. And KubeVirt is a building block for the cloud when we are bringing virtualization into the cloud that runs in containers. And just so you know, I use Spaces. Are there here any top users? Yeah. And you're using Vim? Yeah, that's nice. So, what I'll be talking about is... Oh. Then I'll be using... The presentation is already online. You can use this URL, and I'll be sharing that later. Who am I, and what I will talk about today? So, I'm offering you my view of the cloud and how I learned to understand it, and recently how I try to do cloud native, because for everyone it means something different. And it means certainly something different for me. So this is what I will try to share. But let me first start with my path to the cloud. Am I causing feedback? A little bit. So it actually took longer than expected. Actually, it was something like 17 years that I realized I am working with the cloud. It actually all started when I was something like 19, and I did my first e-commerce system in PHP. It was actually good old PHP set up and deployed by FTP, file transfer, and then when you deployed it, it was just do it by hand, restart the service, and it was hopefully all online. And what was great was that it was all done by hand. So you have to know it was perfect because you done it, right? The good old feeling that you done it. Are there any PHP programmers still here? Yeah, I thought so. Honestly, PHP will never die. So this was my actually first encounter with cloud, because then this is the place when I learned it's just someone else's computer. I just don't own it. Then I actually moved to the university and I started doing distributed computing. This was much better encounter with the cloud, because then I didn't have to do anything by hand. I just written an application, used a framework, an opinionated way how to write an applications, and use a scheduler to deploy it to the cluster, computational cluster. This was somewhat better. I didn't have much options because it was everything thought over. But still, there was this one great sysadmin handling up the multi-million-dollar cluster. Still operational in Austria, by the way. And this was my second encounter with the cloud. This is where I learned that when scheduler does the job, it's better than you. And then I joined Seznam, when I actually work at full text search, and we did scalable applications. This was very nice, because this is where I learned to collaborate with sysadmins and developers. It was certainly something new. And it was certainly not perfect, because it was not dynamic, it was a little bit slow, and you had to be very patient. And everything was manual, right? And this was roughly the architecture at the time. It was 3 years Yeah, I see you like the paintings. I like to draw by hand. This was 3 years or 4 years ago, so I'm not sure if this is the still architecture, but this was at the time. The base search is the BS, it's not bullshit, it's base search. They were the custom-made databases to store the queries. The funnels, they were the filters, those were the aggregator points that were collecting chunks of search results and filtering it up to the bottom. When in the middle, when you see the wheels, this was a component when I was working on. Yeah, exactly. We were what's called meta search. We were mixing everything together and preparing it for layout managers and then spitting it all out for the users. The architecture, as you saw it, was hard-coded. There was nothing scalable in it. We had to prepare for spikes, and the servers were always running. So this actually brought me to realize that nothing is perfect, and that if you can't react to the user load, you will pay a lot of money for the servers running. And all the jobs, it was 12 years of my experience, everything was done manually. And this was actually driving me crazy. And then we started with our own startup. And then we actually created it was not search engine, it was a recommendation engine for food. We were actually solving our own age where we didn't know what to eat. Each of us has some diet restrictions and we need to figure out what to eat. This was great. We are all engineers and we figured that we use the cloud, AWS at the time. We had it all automated, we used containers because it was cool, and we built a perfect product. But we didn't build a better product because we did not have users, but that's a story for a different time. But from the engineering perspective, it was great. There are 3 of us, and we can do a full company because everything was automated and we didn't have to wait for anybody. And all 3 of us can maintain it. This was the breaking point when I realized I love the cloud solutions, and you should too because it will save you time. And it actually helped me to realize that at some point, I was working with the cloud. And even those of you who didn't raise the hands, I believe you are working with the cloud if you're not developing for desktops at a certain point. Which brings me to my last job, when I'm currently working on, and I'm very happy with it. I'm basically working with all the cloud perfectly tools. It's the tooling for Kubernetes that is the hot new stuff in the town. And it's the virtualization project that I'm working on. It is actually a mix of transferring the old technology, because the old one was Red Hat virtualization, to the new one, that's KubeVirt, that will help you bring the workloads in existing clusters. And this is the part when I realized everything can break. And that developing for cloud is not an easy task, and it will drive you crazy. It certainly drives me crazy. Which brings me to tip number 1. Cloud is the state of the mind. Remember that. If you start to work with the cloud and develop with the cloud, switch the old mindset when you have written any application. It's something completely different. What is it? We'll get to it. Just a quick note, sharing the state of my mind is why we started Cloud Native Czechia, and sorry, I already told you that. You should not have put this slide here. So what is cloud? From my point of view, currently, cloud is a big mess. Because there are multiple providers, there are lots of tools, and there's basically a lot of technologies you should learn to work it. But it doesn't have to be complicated, and it can be simple. You just have to figure out where do you start and how to start. So let me help you with the basic orientation I learned how to navigate. It's the level of involvedness. How involved you should be when you work with the cloud. We start from the bottom. It's the infrastructure as a service. Then there are containers. Is anybody here who doesn't heard about containers? And is anybody here who is not working with containers yet? You will. There's a platform as a service, function as a service, and software as a service. Software as a service, I believe everybody is using already because we are using Gmail or some sort of service email calendars. Function as a service, this is something I really would like to talk about, but I don't have any experience yet. Sorry for that. Platform as a service, this is a level where we ended up with my own startup because we did not have any time and any money to invest to have administration. We basically bought everything. Then there are containers. They are somewhere in the middle because they can be both platform or infrastructure. And then there's the infrastructure when you are building the stuff, but you are using building blocks provided by the cloud. And infrastructure is where we start. And this is actually how it looks. This is, you connect computers, you wire it together, and you serve to your user. It's done in a cloud, it's done in an API way, but it's still the old do-yourself build computer. And it's actually one of the simplest way to the cloud. And it's not that different as any other VPS, virtual provider. And it actually is the simplest way that you can move existing application to the cloud. And to help you illustrate that, I will talk about application I was working in, and we will containerize it. The original utility was actually search tuner for our full text. It was a pure old Python web page, written in such a way that it relies on a system-wide packages. It does, and it did a few background tasks, and it was a pain to maintain because it was deployed by a Debian installation to the system. It was hell. So how do you put that in the cloud? You just wrap it in the virtual machine where you can everything package nicely together and swap it out. So that's what we did at the first run. Now, you might wonder, what is the benefit of the normal VPS? Why should I care using AWS, Azure, or G-Cloud? Well, it's simple. Because you can automate. And if you've done that properly, you already automated the stuff. And this is actually a very important thing, because this is the way how we, the team of 3 people, were able to maintain the whole company. We automated the infrastructure. So this is the tip number 2. Learn how to automate, play with the clickery stuff in the UI, and once this is working for you, automate it, because it will save your time. And over a time, when you do changes and you have everything stored in Git, then you will see how you implemented the changes, because it's very hard to see changes in the UI. So now we automate the infrastructure, deployed, and now this question: are we cloud native yet? Let's vote. Are we cloud native? Yes? No. Not yet. Because we are only running in the cloud, and we automate it partially, and we are still abusing the cloud, because this is not the best way how you run it. Still, you're not auto-scaling because you don't want to consume a lot of memory, a lot of resources, because you will pay for them. And you're basically throwing away money because now you're paying a guy who's maintaining the infrastructure. So what you can do, sprinkle some containers on top of it and containerize the search tuner, the application what we are running. This actually requires a few changes to the application when you're transferring it from virtual machine, from the pure computer to the container. Because container is not a virtual machine. And it should be epithermal. So how you do it? You basically don't want to read configuration from disk. You read it from a virtual and from environment. And please, don't store any data near your application. Store it on the mounted volume or by any other mean. And don't embed the database, because this was the first issue we had. We embedded a database, and this was the biggest mistake we did. So we moved it outside. Then you can package everything in the container and run it, and it will run. So everything runs in the container. Now update the infrastructure scripts because we automated it, and deploy. Are we cloud native yet? Just guess it. No, it's obvious because I will not be asking. We're still barely using it, but we're getting better. And we can do even better. Tip number 3 from me, automate not only your infrastructure, automate even your development workflow. Because again, it will save you time. Quick tips how to do it. If you're not doing it so, cover your application with tests and play it safe. Because this will save you, again, money. If you don't test it, it does not exist and it will break. Then use the power of deployments in the cloud and deploy only partially. Don't deploy for all your users. Just 10% is enough and test it. Once this is workable, do a rollover and do it for all users. And then I know this is cliche and you heard it a lot, but deploy as often as you can. But not everybody will tell you why. So I try to explain. If you deploy as often as you can, you are deploying small features. If the feature is small, there is a lower probability that it will break. And this is what you're targeting. Because if you deploy small features, they are not just simple to debug, not just simple to test, but they are even simple to roll back if there is a problem. So this is why you deploy small. Don't do it monthly, because then there's a ton of features and you will not know what has broken your deployment. And as I said, be ready to roll back because issues will happen, and not only on your side, but sometimes a cloud provider fails. So while we are developing the app, tip number 4, save yourself time and switch to Lego mindset, because cloud is rich of services and components you can already use. We talk about virtual machines, containers. There are now functions you can use, you can build. But there are other building blocks, such as services. And this will save you, again, a lot of time. When we built a recommendation engine at the time, we built our own recommendation engine, because there was not that well documented and not that well served services for that. Now, honestly, I would just buy a machine learning instance and do it there. Because at that time, we had to build the knowledge, and it was not simple. And it cost us money. We burned through our reserve cache very fast. Now, it would be simple. I just pay for a small instance of machine learning that exists and use it. Because services are, for me, they are like libraries on steroids. You're not just buying code that you can use that's already debugged and well tested. You are buying expert knowledge from someone who sits there and verifies that this model is working. So I cannot stress this enough. If you are starting, or even if you are porting an application, figure out what you can use and use it. It will save you time, save you money, and save you stress. And until the time, when the time is ready, then you can move to your own services. Because at some point, if you are big enough, it's simple for you to build it. But at the time, you will have the knowledge. So for us, when we want to do a little bit more, we choose a hosted database and we use object store, because the application was not that big. So we are now running in the containers. Everything is automated, and we swapped everything outside. Are we cloud native yet? Almost. Technically, yes, but still we can do better. And this is the final step, what we did. This is what I said earlier. The last step, what we did to be cloud native and save us a lot of time, was to buy a platform. Because maintaining an infrastructure with virtual machine and setting up the containers ourselves was a tedious task. So we offloaded the maintenance and bought ourselves a container service. At that time, it was just pure elastic container service that you just said how big you will be, said that you want to auto-scale, and you run the containers. Now, it's much better. I have experience with Azure and Amazon, so pardon, I'm omitting the Google. For us, it was Amazon. Now, I would just go for Amazon Fargate. It's auto-scaling, and it's the less pain you can use. In Azure, I would go for Amazon Azure Container Services. It's basically equivalent for Fargate. Again, auto-scaling and simple to use. Be careful, you're paid for that, so you have to know what you're doing. And enable auto-scaling, because then you will not pay for what you're not using. And tip number 5, be careful. You pay for everything in the cloud. And this is what we learned even in our startup. Because at that time, we put things a little bit further. We're not just using a container instances, we were using an application platform. We're using a Beanstalk. Beanstalk was at that time equivalent of App Service in Azure or App Engine in G-Cloud. You had a framework where how you write the application. You write it, you deployed it, and Amazon does its best to maintain it. If you're building a simple application, I would preferably go for such a framework and then scale out once it's needed. It's needed. But read the documentation, because we didn't. And then the bill came. It was roughly $100 for one night. Luckily, we set up alerts. So everything was, all infrastructure was deleted, and then we did report what we did wrong. We failed to learn that if we set auto-scaling, it will install automatically load balancers. And the load balancers are costly as hell. And there were 2 of them running nonstop. And they were not the small ones, they were the big ones. Because this is how Amazon will try to screw you. It will give you the bigger instance if this is not needed. Read the documentation and tune it. It's not that hard, and it will save you money. But, again, if you use it properly, it will save you time, and you can build application faster. Save you a little bit stress. And now you might be asking, okay, there's a lot of cool features I can already use. So how does the Kubernetes here fit in? Well, it's simple. Just a quick check, sanity check. Is anybody here who's not aware of Kubernetes? Is anybody here using Kubernetes already? Cool. So the Kubernetes should be the platform that is providing you the same level of experience everywhere. You will use the cloud. It doesn't matter if it's AWS, Azure, Google, and it's running on-premise. There is this Kubernetes and extensions running on top of it with some core add-ons and your custom add-ons. As an example, one of the custom add-ons could be a KubeVirt that adds a virtual machine running in the Kubernetes. And then using the building blocks, at the top level, you run your application. Well, certainly this is a theory. You can guess if this is the reality. Currently not. Because providers are trying to do their best to serve you the best experience they can get you. That means extending and integrating Kubernetes into their own environment. At Azure, there's Azure Kubernetes service. At AWS, there's an Elastic Kubernetes service. And those are integrated well in the environments, and they actually work flawlessly. The issue is they are not the same Kubernetes that run everywhere. They're fine-tuned. And those are the small changes that will make the difference. So if you want to make the platform everywhere the same, you have to deploy it the same by yourself. You go for infrastructure and deploy it yourself. Then it will be perfectly working everywhere. It's just more work. And if you want to be lazy, and you are a big company, you can use opinionated libraries or frameworks such as OpenShift. This is a distribution of Kubernetes that actually provides an opinionated way that's mixing up the services, the core add-ons, and the Kubernetes. So if you install OpenShift, you will get the functions as a service. You can get the virtual machine as a service inside the OpenShift again. And you will certainly have CI/CD integrated. Everything is in place. You can use your custom add-ons if you want them, and then you run your cloud-native application. And again, you run it everywhere the same. And again, there's a twist. You have to run it by yourself. But if you're a big company and you really need it, you have the resources and money to do it. So this is how the Kubernetes fit in. It's trying to provide the same level of user experience, how to run the applications everywhere. And already it's offered on the major clouds, and it's smaller than I expected. So this is actually the core cloud-native computing foundation add-ons. This is the components from which you can build your applications. There are Kubernetes distributions, there are service meshes, there are add-ons. If you want to learn more about that, just Google Cloud-Native Computing Foundation Landscape, and it will pop up an interactive map with nice explanation, basically, of every component. This is what you will use if you're building your platform. If you're not building your platform, I'm stressing, just use whatever out there and focus on your application. So to wrap up the tips I'm trying to give you, change the state of the mind, because this is how you go cloud. Automate everything, because it will save you time, money, and your sanity. And embrace Lego mindset. Oh, there's a typo. Embrace the Lego mindset. Put existing components together and save time. And be very, very careful, because in cloud you pay for everything and it can destroy your budget. So now, thank you for your attention, and let's get to questions if you have any.
Thank you, Peter. Now, we have a Slido. I kind of screwed up because I didn't tell you, but we have a Slido prepared. So if you join, you can leave the questions there. But because we don't have questions right now, because you didn't know, you can ask by simply telling us right now. So any questions?
Hello. Thanks for the great presentation. So my question is, you're trying us to automate everything in your business. So is any bottlenecks in there? Because as you know, Elon Musk, for example, trying to automate everything, and it was a hell at some point. Maybe there is something.
Well, there are certainly many bottlenecks. It all starts with a human interaction. If you're automating how to deploy your infrastructure, that can be done. There's an API for that. If you want to deploy your application on top of your infrastructure, again, you can do it simply. There's an API for that. If you want to test it and you can do it in an automated way, again, you can do it. The bottlenecks come when you are using when you're developing UI and you want someone to click it through, or test for some randomness, or test for something that cannot be automated. In our example, the bottleneck when we are testing in the queue, when we are developing the virtualization, we have to test installation of the Windows in the virtual machine. There's no way how you can do it by automated way, because there is no automation script, there is no API. So if I try to answer that simply, if there is no API, that's the bottleneck.
Okay, thank you, Peter. Now, we have one question on Slido. Why not use databases in containers?
Oh, well, this is a tricky one. Evidently I failed to explain it better. I discourage you to put database near your application, so they run both in the container. I meant run database outside of your application. And then once we are in the topic of running databases in the containers, not every database is well suited to run in the container. Let's take an example and take a minute of silence for Oracle database. It's a big, hefty database that was never designed to run in the container environment. It relies on a configuration outside provided outside. It relies on a system-wide packages, and it basically hogs up everything, all your resources. It's well suited for virtual machines. It's not suited for containers. And it's not counting for storing a data in the mounted volume. It can be hacked around, but I would not do that. It's not designed to work on mounted volumes. If you want to run database in the container, I would go. What I played with is MySQL, the new MariaDB, when it's more or less designed to work in the containers. Does it answer the question?
All right, thank
Hopefully.
you. So this is not a question, but maybe can you talk more about legal context? I'm not sure what it means.
By the legal context, you mean the data, who owns the data, or if I use the service, who... Okay, I will try to answer it as I understand it. If you're using services, you of course are accepting the license agreements, and the license agreements are clear even on AWS and on Azure, and I hope on Google Cloud also, that you are the one who owns the content. And you are the one responsible for the content, and you only. So there is no stealing the data.
You're not.
And if you are aware of someone piggybacking on your infrastructure and listening what you're doing, honestly, what you can do. Are you using cell phones? Because there's someone piggybacking on your infrastructure and listening what you do to provide you a better service. And the same applies to cloud. What I've actually heard from Microsoft telling them, they are listening to the infrastructure. They're not analyzing the content, what's passing through the infrastructure, they're analyzing the traffic. So they can learn how to build a better service. And again, this is in their license agreement. They're long, they're freaking long. I didn't read them. But I know this is a pressing question, and for future meetups we'll be holding in Brno. By the way, they are recorded and placed online. I've managed to ask a lawyer that will help us to answer these questions. It's not settled for the date yet, but we will be having a discussion with a lawyer who will help us to understand.
So may I just follow up on this question regarding maybe GDPR or this data? Because I hear many FinTech services saying that you can't really go to cloud yet. What do you think about this? Like they are maybe afraid of maybe losing the data, or do you think like is it possible for a FinTech right now to actually be in a cloud, fully in the cloud without being on premise at all?
This is a tricky question that depends on multiple aspects. First, how the license is set up, where the data can be. I know this is certainly a question for many fintechs. This is something I'm not standing fairly on the ground because I don't understand and I don't work with the licenses. Regarding the technical aspects, I believe that every major company can move to the cloud now, if they are willing to place money on that, because it will cost money. This is the question. Are you willing to pay for that? If yes, the transfer is possible.
All right, thank you. So now we have one more question about performance and databases. So do you want to separate databases from Kubernetes to a VM, for example?
Good question. Well, there is a known factor for Kubernetes. It has an performance hit. Because, for instance, Rook, if you link a Ceph storage, this is a block storage you can install and provide a block storage. And if you directly link it to Kubernetes, it's 10 times more performant than if you use it through Rook. Rook is an operator that abstracts a communication and a link to the Ceph. The slowness comes through the nature how Kubernetes works. There are proxies that proxy the connection from the Ceph storage to your application. I'm guessing, because I did not play with databases, I play with the Ceph, that the same could apply to databases if they are used from some proxy. If they are not, I'm not sure if they will be having the performance hit.
Okay, thank you. Does anybody have more questions? So thank you all. Thank you, Peter.
If you have any other questions, just catch me.